Okay, so I'm going to be showing you how to find the greatest common divisor of 16, 24, and 36. The first way I'm going to be showing is a prime factorization. So we're going to bring down 16, 24, and 36. 16 could be 4 times 4, 24, 6 times 4, and 36 will be 6 times 6. Now we have to break it down even more because you could still break these down. So this will be 2 times 2, 2 times 2, 3 times 2, 2 times 2, 3 times 2, and 3 times 2. And we're going to circle the ones that they have in common. So this one has a 2, this one has a 2, and this one has a 2. Next, this one has a 2, this one has a 2, and this one has a 2. And as you can see, that's all they have in common because then these have 2. This one has 2 2s, this one has 1 2, this one has no more 2s. This one only has 1 3, this one doesn't have a 3, and this one has 2 3s. So we bring these down, so it's 4, 4, and 4, because 2 times 2 is 4, 2 times 2 is 4. So the GCD would be 4. That's what they have in common, all these numbers. Okay, so my second way is listing the factors to find the GCD of 16, 24, and 36. So we're going to arrange them in this form, and we're going to list the factors of each number. So 16 would be 1, 2, 4, 8, and 16, because 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. So those are the factors of 16. Now for 24, we have 1, 2, 3, 4, 6, 8, 12, and 24. And for 36, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. And now we're just going to circle the ones they have in common. So I see a 4 right here, a 4 right here, and a 4 right there. So the GCD is going to be 4 because that's the biggest number they have in common. There's a 6 and a 6 right here, but this one doesn't have a 6. So the highest one is a 4.
Okay, for the last and final way of showing you the GCD of 16, 24, and 36, I'm going to be using the Euclidean algorithm. So we're going to start off by using 16 and 24. We're going to try to find the greatest common factor of those two numbers. So we're going to start with 24 equals 16. The bigger number always has to go out on the outside because it's like if you're dividing. So we're going to do 16. We're going to multiply by a number. We want to get to this number. So 16 times 2 would be over this number, so that's why we just put 1. And then we're going to add 8 because that will give us 16 plus 8 equals 24. Then we're going to move this over and this over. So we have 16. We have to do that until we get 0. So 16 equals 8 times what plus something. So what times 8 equals 16? 2 will go here, and then you finally have 16, so you put your 0. So since 0 is a remainder, 8 is your greatest common factor of 16 and 24. And now since we have 3 numbers, we're going to have to use this one and use 36. So
we found out that the GCD of 16 and 24 was equal to 8. Now we're going to use this GCD and use 36 from over here to get the final GCD of the whole thing. So we're going to do 36 on the outside equal to 8 times, so what times 8 will get close enough to 36 but not over it. So we're going to try 4 because that equals 32. And then 33, 35, 36, you add 4. And then you bring that over down, and you have 8 equals 4 times blank plus blank. So 4 times what equals 8? So we're going to do 2, and then we finally have 8 right here, and then that's 0, because we don't need any more. So we have our remainder, and this is our GCD. So the GCD of all three numbers is going to be 4, because we found out the GCD of 16 and 24, but we had to find out the final GCD of the 3 numbers. So this is the final GCD of the 3 numbers, as we got in the same result in the previous methods.